Hi there. Here's example 2 from the Managing Inference Errors review. So this time we are given already the confidence interval. I know the sample size is 220, and this confidence interval is a confidence interval for a proportion, the proportion of male seniors from Hamilton County schools that have taken the SAT. And our job is to find the level of confidence for the intervals. So we're going to have to do a little bit of working backwards, but this is once again still managing the margin of error. So remember, the margin of error is built using the critical value, the standard deviation, the statistic, but this time the statistic is a proportion. So this is the standard deviation relationship that we need to be using. So notice I need n, I know that's 220, but I'm going to have to be clever and find my value for p. Okay, so first of all, I don't know the level of confidence, but I know it's going to be a z-score. And that z-score will help me determine the level of confidence. So I want to come up with the formula then for the standard deviation for the sample proportion, and you should remember that exactly in the middle of the confidence interval is the sample statistic. So if you find the average of 0.857 and 0.770, so literally what I'm going to do, I suppose I will show it to you on the calculator, I'm just going to take the average of those two in order to find the middle. So that's the 0.857 plus the 0.770, and I'm going to divide it by 2. This 0.8135, that is the p hat that is in the middle of this confidence interval. So that's my p hat. So that's what I can use in the numerator of the standard deviation. So I've got the 0.8135, and then I've got 1 minus the 0.8135. There we go. So I know my sample size is 220. Very good. So this is the margin of error. So to find the margin of error, again, I can take the width of this confidence interval and divide by 2. Because remember, you add and subtract the margin of error to the sample statistic. So I can take the 0.857, and from that I can subtract the 0.770. So that tells me that this confidence interval is 8.7% wide. And if I cut that in half, that tells me the margin of error is 0.0435. So literally, if I started at the 0.8135, if I added and subtracted 0.0435 from that, that would give me the confidence interval. So that confidence interval, along with the sample size, gave me everything I needed in order to solve and work backwards to find this z star. So I'm going to take a second and figure out what this crazy radical is. 0.8135 times 1 minus 0.8135. And we will divide that by the 220. So this is 0.0435, and that should equal the z star that I'm interested in. And that standard deviation of the statistic is here we'll call it 0.0263 is approximately what that rounds to. So a little simple solving there. 0.0435 divided by the 0.0263. Here we go. So that turns out to be about 1.654-ish. That's z star. And I would hope that you recognize that. That suggests 90% confidence, and let me show you why. So you might already have that memorized. If you remember from example 1, we saw the z-score of 1.96. That's for 95% confidence. 1.65 approximately gives you 90% confidence. If you weren't sure of that, you could have taken the time to do this. We'll review the calculator command. So literally what that z-score says, if I start with a z-score with a mean of 0 and a standard deviation of 1, as z-scores will have, so in this context, the 1.645 is up here, or excuse me, 654, forgive me. That would be my upper boundary. My lower boundary would be negative 1.654. And if I wanted to, I could use the normal CDF command to find the area between those boundaries. Again, this is not something that you have to do, but something I would want you to remember. Negative 1.654 up to positive 1.654. And there you go, there's the 90%. The difference is essentially rounding error. So this really is 90% confidence. And we are good to go. The level of confidence, 90%.